People, welcome back to the channel. Today we're looking at forwards and backwards scanning through an activity network and critical path analysis from that network. So what we're talking about here is finding out the earliest possible start times and the latest possible start times for activities in a project. So based on the different timings of activities, some activities may be able to start later or earlier, depending on the prior activities. Right? And when there are multiple activities, we also need to be able to analyze what the earliest finish time is for those as well. Okay, so we'll kick off with this. We start with what we call forward scanning. Okay, forward scanning starts with me getting a pen color I like. There we go. Okay, so this means that for the first activity, that can start at 0 hours. All right, we'll call them all hours. So regardless of which way we go. Now, E can start 1 hour later because A's activity takes 1 hour. So E can start at 1 hour. C, however, can start at 2. This is actually C and D's start time. All right, just applies to anything coming out of this vertice here. Okay, so B takes 2 hours, so C can start after 2 hours. Now we can keep running along this. So F can start after 6 hours. Right? And from that, we can see that also G can start after 4 hours. Okay? So it's 2 hours to complete B, 2 hours to complete C, so G takes 4 hours. G can start after 4 hours. Now, this is where, at this point, we get to the first, I guess, tricky or small thing that we need to consider. Okay, H can start after E's finished, F is finished, and G's finished, but not until all of them are finished. So E finishes at 4 hours, F finishes after 8 hours, and G finishes after 9 hours. Okay? So from that, hopefully we can see that we have to choose the largest number when we're forward scanning. All right? Because anything prior to 9 hours, G isn't finished. E and F are, but anything prior to 9, G isn't finished, and H can't start until all of them are completed. So we use the largest value when we're forward scanning. So there's our 9. So H starts after 9 hours, regardless of the fact that E's done and F is also done. Okay. And then H is completed after 1 hour. So the finish time is 10 hours. Right. So that's our forward scanning. Then we do our backward scanning. The backward scanning gives us our latest possible start time. All right. So our latest possible start time, we want it to finish at 10 hours. So that doesn't change. That stays at 10. Okay. 10 minus 1 means that H can start at 9 hours. Okay. Now I'll go across the top here. 9 minus 3 means that there is 6. Okay. You can see now that E can start after 1 or anywhere between 1 and 6 hours. What that means is that won't affect the finish time of the project if it starts between the 1st and 6th hour that the project begins, because we know we've got this big gap until G's finished, okay? And that creates the float time here for E. Moving down from 9, so we're calculating from these second boxes now, from 9 hours, we can see that F, if we subtract 2 there, we get 8, right? And the start for F has a float time of 8 hours. And G, 9 take 5 is 4, so that doesn't have a float time. Right, so I've done 9 take 5. Okay, moving back one more place, we can see we get to a point where we've got to analyze F and G when we get to the start of B and C. So 9 take 4, sorry, 4 take 2 equals 2 hours, and 8 take 4 is 4 hours. So what we want to do when we're backward scanning, we want to take the lowest number for the start time. Okay, so forward scanning, we take the highest number as we did over when we got to H. Backward scanning, we take the lowest number. So we're going to take the 4 take 2. All right, so that's 2 there. Now we've got to analyze back to our start points. So 6 take 1 equals 5, and where was I? 2 take 2 equals 0. So there we have 5 for that and 0 for that. 0, not a 6. Okay, so that's our forward and backward scanning done. All right, now from this we can tell float times, as I mentioned earlier. So if we look along the path of AEH, we can see we've got float times of 5 hours for the start of E, and also 5 hours for the start of A. All right, but obviously if A starts at 5 hours, E can't start as late or 5 hours later again. It's got to start at the 6 hour mark. Okay, so A can start as late as the 5th hour mark, E can start as late as the 6th hour. And if we go down B's route, we can see that B, C, G, and H have no float time. So there's 0, 0, and 0 along that path. If we take the BDF option, we can see that when we get to F, we've got a 2-hour float time there. So F can start after 8 hours. Right. Now what that brings us to is our critical path analysis. The critical path analysis is the path in which nothing can be disturbed or no time can be lengthened without it affecting the completion time of the project. Okay, so this project is taking 8 hours. The critical path is the path in which all float times are 0, and there will be one in every activity network. So if we look at this, the critical path is B, C, G, H. Right. And like I said, it's called the critical path because if anything time-wise in that is disturbed, then the length of the project is blown out greater than 10 hours. All right, and obviously any project we want completed in the minimum possible time. So B, C, G, and H is our critical path. All right, so that's how we do forwards and backwards scanning. So remember, forward scanning, occupy the first box, add up the time of each successive activity, and when you get to a point, this point here, when you get to a point where multiple activities merge, then you take the highest value of all those activities. Backward scanning, the second box, put the same value in for the finish time and subtract each value associated with the activity. So 10 minus 1 was 9, 9 minus 3 was 6. Then that gives you your float times for each activity. Okay. From there, you can then conduct your critical path analysis by finding the path where there are float times of 0 the whole way through. I hope that's helped with everything there, gang. Have a great day. Hopefully the sun's shining where you are, like it is for me right now. And yeah, get out, get some vitamin D. Enjoy your critical path analysis. See ya.